Okay, our last subtopic 3.9 potentiometer, and we have two linear outcomes. The first one is explain the principle of potentiometer and their applications. Number 2, use related equations for potentiometer, and this is our equation. EMF 1 over EMF 2 equals to L1 over L2. It is similar with potential divider. Okay, so what is potentiometer? Potentiometer is mainly used to measure, the potential difference, which is V. And it is consists of a uniform wire. Okay, usually we use a uniform wire, and you can find the potential difference for that wire. Okay, basically, a potentiometer circuit consists of a uniform wire AB. Okay, potentiometer consists wire AB of length 100 centimeter and must be connected in series. Okay, series to a driver cell. Okay, to a driver cell with EMF V of negligible internal resistance. So we ignore the internal resistance of dry cell or battery. This is our simple diagram, okay, or circuit of potentiometer. You will have driver cell or accumulator. Okay, then we have wire AB. Okay, we have the wire A until B. That one is in 100 centimeter. Okay, and we also have the unknown voltage connected parallel with AC. Okay, parallel with AC. Okay, from here to here, that one. Okay, so you can find the unknown potential difference across AC. Okay, and how to get the reading by using the galvanometer. The main concept in potentiometer is we need to make sure our potentiometer is in balance. Seimbang. Okay, when the jockey or sliding contact is at such a position on wire AB that there is no current through the galvanometer. Thus, the galvanometer reading is equals to 0. Okay, or current across galvanometer equal to 0. Like this. Okay, I repeat once again. Your potentiometer must be in balance. Okay, must be in balance when you slide your jockey at a certain point. Okay, so then no current can pass through the galvanometer. When the potentiometer in balance, okay, the unknown voltage or potential difference being measured is equal to the voltage across AC. Okay, I will explain about this later. Okay, you just need to remember that your potentiometer in balance, current across galvanometer equal to 0. Therefore, unknown voltage is equal to the voltage across AC. Like this. Okay, potential difference across X, okay, across X equals to the potential difference across wire AC. And this is the application of potentiometer. Okay, application of the potentiometer. Potentiometer can be applied to measure unknown EMF of a cell. Second, compare the EMFs of two cells. Number 3, measure the internal resistance of a cell. So we have 3 applications and we will discuss all these 3 cases. Now I will explain about the concept in potentiometer. So I will draw a simple circuit for you. Okay, this is the battery, the main dry cell, and connected through a wire. And I label this one. This is wire A to B with the length 100 centimeter basically. Then we connected with other battery at the lower side. And also have the galvanometer and the jockey. Okay, so that's our jockey. And I label this one as EMF and this is as VX. Okay, now as we know, dry cell or battery, you have the positive terminal and the negative terminal. And of course, the current flow, it comes from positive terminal, right? So this is the current flow. And now, your current reach at this junction. And what happened to the current? Okay, current will be split into 2 parts. Okay, 2 parts. In this wire and also in this wire, right? But the concept in potentiometer, we do not want the current flows in lower circuit. Okay, in lower circuit. It means no current can pass through this wire. Okay, no current can pass through this wire. So what happened to the current? This red color, the red current, just flow in upper circuit, and this is flows from EMF. Okay, from EMF. That's it, in above circuit. Now look at to the lower circuit. Okay, to the lower circuit, we also have the battery, isn't it? But now you already set your reading of galvanometer. Okay, the reading of galvanometer, which is your I across galvanometer, it is equals to 0. No current, because there's no current, right? No current. That's why your Vx, it is not function. Okay, not function. Why? Because there's no current can flows out. Okay, so this is the concept. Current across galvanometer equals to 0. And this is when potentiometer in balance. That's why we need to make sure it is in balance. Then you can calculate the values. If it is unbalanced, you cannot determine the potential difference. So the clue is make sure you know the concept. Okay, the concept is make sure it is in balance. Okay, in balance. Okay, then I label at the jockey point as the point C. Okay, look at to the point A to C. Okay, A to C. A, C, and also Vx, your lower battery, it is in parallel. In parallel, Okay, this is in parallel. And when it is in parallel, therefore the potential difference across wire AC is equals to the potential difference of battery X. Okay, it has the same values because in parallel. Okay, so that's the basic concept in potentiometer. Now I will explain about the first application of potentiometer, which is measure an unknown EMF of a cell. Okay, we want to find the unknown value of EMF. Alright, this is our simple circuit. We have dry cell as our accumulator. You have unknown EMF. Okay, so this is unknown value because we want to find that EMF. And you have the jockey right here and also wire AB with 100 centimeter. Right, look at to the basic concept of potentiometer. Okay, once your potentiometer in balance, okay, in balance, your current across galvanometer is equals to 0. Okay, so means there is no current can pass through the lower circuit. Okay, the lower circuit. And we will have the balance length. So what is the balance length? That one is length wire A to C. Okay, A to C right here. Okay, so this is our balance length LAC. Why this is imbalance? Because you already set your jockey contact at this point and no current across your galvanometer. So that's why this is the balance length. And of course, once it is in balance, EMF of unknown cell, okay, is equals to the potential difference across AC. So our objective right now, we want to find this EMF. Okay, but before that, you need to know the value of VAC. Then you can identify the value of EMF. Alright, back to the basic concept of Ohm's law. To find the potential difference across AC, okay, across AC, we just use VAC equals to IRAC. Okay, IRAC. And AC is a wire, right? It's a wire. Therefore, you can use the equation of R equals to rho L over A. Okay, you can use this one to find the resistance of AC. But we don't have the length of AC, right? Okay, doesn't matter. Okay, same goes with AB. Okay, AC and AB, this is occur in the same wire. Okay, the same wire. So in the same wire, your rho resistivity, okay, rho and A, which is resistivity and surface area, are constant. Okay, this is constant, are the same because same wire. Okay, because this is same wire. Sorry, I use other color. Okay, because this is same wire. Okay, same wire. And you can do the ratio lah. Okay, just do the ratio between equation number 2 and equation number 3. After that, the equation become like this lah. RAC equals to LAC over LAB multiplied with RAB. Okay, after you do the ratio, you can cancel out your resistivity and cross-sectional area. Alright. And you can rearrange your equation by using Ohm's law. Okay, current. Okay, you can find the current. You can find the current. The red current. This one. This one. You can find this current. I equals to V over RAB. Okay, RAB. Because you use the whole wire of RAB. And usually it is given. Okay, given. RAB is given. And why we use the V? Why we use this V? Okay, it is because like this. Okay, I take it outside. This is your battery. Okay, and this is the wire AB, right? Right now, this is a wire. Okay, AB is a wire. So it is like a resistor. Okay, it is like a resistor, a long resistor. And this is the V. Therefore, if you want to find the VAB, of course it is equals to the V, right? That's why, by using the Ohm's law, VAB is equal to IR. But which R? RAB. Okay? Right? Because AB, it is like a long resistor. Okay? So you can use this one. Clear? Okay? That's why I told you RAB usually given in examination. Okay? Or in question lah. Okay? Otherwise you will stuck. That's why you will provided with the value of RAB. Okay, then you can combine equation number 4, okay, number 4 and 5 into number 1. Okay, this one number 4 and number 5 into, okay, number 4 and 5 into number 1. So then what happened? Okay, so because EMF equal to VAC, okay, and we change into Ohm's law. V equals to IRAC. Okay, this one, IRAC. And I is this one. Okay, I equals to V over RAB. Okay, then RAC is number 4. This one. Okay, this one. RAC is equal to LAC over LAB multiplied with RAB. Alright, then you can cancel. Okay, you can cancel out the RAB. Okay, the RAB. Okay, then you can have your equation how to determine unknown EMF. Okay, by using LAC for the balance length, usually given, and the whole length of wire LAB, which is in 100 cm, and this is the main supply. So you can have, okay, you can have the value of EMF. Settle. Okay, I will show you the simple method to find the unknown EMF by using the potential divider. Okay, as we know, once you set the potentiometer in balance, the current across galvanometer is equals to 0. Okay, I across G equals to 0. So means no current across the G. Same goes at this wire. And we can know current just flow in upper circuit. Okay, in upper loop. So no current in lower loop. So when no current across galvanometer and also that wire, this EMF is not function. Okay, not function because no current from that EMF. So once your galvanometer already in balance, we have the balance length. Labeled as LAC. Okay, therefore, the potential difference across AC is equals to our EMF because in parallel to each other. Okay, once galvanometer in balance, okay, the parallel connection will be occur. So VAC is equal to EMF. Right. And I will draw the upper loop. Okay, like this. Right, so this is our driver cell. Point A, point B. Okay, because wire AB, and this is our point C, the balance point. And I will label the length. A to C is our balance length, LAC, and A to B is our the whole length, LAB. Right. And now we know your current just flow in one loop. Okay, so the same amount of current across A, C and CB. So means this is in series. Okay, in series. Therefore, you can use the potential divider because the principle of potential divider, resistor in series, you can use it. Okay, you can use the potential divider. Okay, and I want to do the ratio between VAC to the VAB is equals to IRAC over with IRAB. And this same amount of current, just cancel out your I, and then I change the R with length. LAC over with LAB. Why I change to the length? Because we know that your R is equals to, okay, resistance of a wire. Resistance of a wire is equal to resistivity times with the length over with area. And rho and A is a constant value. Okay, constant value, the same wire. Okay, same wire. Right, same wire, it is constant. Now, resistance is directly proportional with the length, so we just change it. Then what happened? Okay, I rewrite VAC over with VAB is equals to LAC over with LAB. And we want to find VAC, right? Because VAC is equals to EMF connected in parallel just now. Okay, then just rearrange your equation lah. Okay, just rearrange your equation. Make it your EMF as the subject. Okay, and this is LAC over with LAB multiply with VAB. Okay, and this VAB, okay, your VAB is equals to this V right here. Okay, the concept in series. That's it. Okay, simple. Okay, method 1 and method 2, it is the same step, but it is more simple. Okay, our second application of potentiometer is compare the EMFs of two cells. Means you have two dry cells at the lower loop. Alright. As usual, you will have the dry cell, your main supply, and you have EMF1 at the lower loop. Okay, but you know the value of that EMF1 and EMF2, which is unknown EMF, means you need to find it. Okay, and as usual, you will have the wire AB in 100 centimeters, and of course we have two balance length, okay, at point C and also at point D, because you have two EMFs right here, okay, EMF1 and also EMF2. Okay, to solve this problem, okay, just use our previous method. Okay, you do the ratio, find the LAC and so on. Okay, end up you can have the equation as EMF1, okay, EMF1 equals to balance length, okay, balance length LAC, okay, because it is about your EMF1, okay, LAC multiply with the V, okay, and then over with the whole length, okay, the whole length LAB. Okay, so that's for EMF1. Next, for the unknown EMF, your EMF2, right here at the below one, EMF2 equals to balance length, okay, balance length LAD. This is LAC, sorry. Okay, and this is LAD, right here to here, LAD. Okay, so that's your second balance length for the second EMF. Okay, so balance length LAD multiply with the V, okay, over with the whole length, which is LAB. So you already have two equations, equation 1 and equation 2. After that, you can do the ratio. Okay, just do the ratio between equation 2 and equation 1, like this lah. Okay, EMF 2 over with EMF 1 equals to LAD over LAB multiply with the V over with LAC over LAB, then multiply with the V. Then you can cancel out the same value. Okay, the V, the length of AB. Okay, after that you can have the equation EMF1 over EMF2 over EMF1 equals to, okay, EMF2 over EMF1 equals to LAD over LAC. After that, you can find your EMF2. Okay. Our third application of potentiometer, measure the internal resistance of a cell. Okay, and this is our circuit, right? You have the dry cell or accumulator. Okay, you have the wire AB in 100 cm, and at the lower loop you have the other battery consists with internal resistance of the battery and also the external resistor. Okay, so we can see that your current from this V, okay, current from this driver cell or accumulator just flow in upper circuit. Okay, just flow in upper circuit. Alright, why? Because as we know, in balance condition, okay, of potentiometer, if your potentiometer is in balance, current across galvanometer, it should be 0. So there is no current can pass through this wire. Okay, and of course we will have the balance line, okay, as usual, line LAC, because you touch the jockey right here. Okay, you have the jockey right here, okay, at point C. Right, then what happened? Okay, at the lower circuit, even though this is no current flow, okay, at the both wires, but at the lower circuit you have a complete circuit, okay, complete circuit, complete loop. Okay, so complete loop, you have the battery with the positive terminal, negative terminal, internal resistance and also external resistance. So no wonder you will have the current I1, this blue color. Okay, so this blue color is current from EMF, okay, from this EMF. Alright, okay, so after your potentiometer is in balance, your VAC, okay, VAC, okay, AC, W, X, okay, W and X, and also Y, Z, okay, are connected in parallel, okay, parallel. So once all the connection are in parallel, VAC is equals to, okay, VAC equals to potential difference, okay, potential difference across wire AC equals to the potential difference across WX, okay, right here, okay, this one is equal to this one, and also equals to potential difference YZ at the lower one. Okay, because it is in parallel. Okay, then by using the Ohm's law equation, V equal to IR, so VAC is equal to IRAC. And for VYZ, okay, for VYZ, okay, at lower one, okay, at the lower circuit, VYZ is equal to I1 multiplied with external resistor, okay, external resistance. VYZ equal to I1 R. Okay, so that's the difference, okay. VAC caused by this current, okay, caused by this current, but for VYZ caused by current 1, okay. It is like separated circuit, okay, separated loop, upper loop and lower loop, because both are function. Okay, based on all the basic concept, VAC, okay, your VAC is equals to balance length LAC over with the whole length LAB multiplied with the total voltage, okay, the total voltage. Okay, if you can see it from this equation, it is similar with potential divider, okay, potential divider, okay, like this. VAC over with VAB, okay, equals to LAC over with LAB. Okay, this is how the step to find the voltage by using potential divider. Why we use the potential divider? Because okay, so that's your battery. I use the upper loop, the upper loop. Alright, so this is like a resistor, and wire AB, and this is point C right here. Alright, and as we know, my dear, this is VAC, isn't it? Okay, V, potential difference across A to C. But then for AB, this is consists for the whole wire AB. So this AB, it is similar with this V. Okay, similar with this V. Okay, similar with or equal to the total potential. Okay, that's why I said it is our potential divider. Okay, so you can get this equation lah. This equation. Okay, potential divider. Okay. To find the current I1, okay, to find the current I1, just rearrange this equation. Okay, just rearrange this equation. So you can get I1 equals to VYZ over with R. And we know that VYZ, okay, VYZ is equal to VAC. Is equal to VAC. This one. So based on equation number 1, okay, you can determine the VAC, right? So after that, just substitute into this voltage, okay, into this VAC. Alright, and by using EMF equals to I1 multiply with internal resistance, okay, I1 multiply with internal resistance plus with I1 multiply with external resistance, because you already have the value of I1, isn't it? Okay, from the previous calculation you got this value. Okay, you got this value and this value. Okay, so you can find the unknown internal resistance. Okay, settle. In potentiometer, okay, for your information, in potentiometer you need to combine all the concept, okay, all the basic concept start from the equation of Ohm's law. Okay, all the best. Thank you. That's it for chapter 3. Bye.